I welcome you all for the second webinar session on Basics of Biomedical Instrumentation. Let us start the session with a wonderful quote. Without your involvement, you can't succeed, and with your involvement, you can't fail. So this is today's positive quote. So you have to do your work with full involvement and get success. Now let us move to our subject. So in the last session, we have discussed about what is instrumentation, what are the different mechanisms in instrumentation, and how this instrumentation is working in biomedical field, right? So in this session, we are going to discuss about what is electrodes, how it is useful in medical field. Let us discuss now. So now we are going to discuss about what is electrode, what are the types of electrodes, and what are the applications of electrodes. First, let us discuss what is electrode. So, we all know that what is electrode. Already we have studied in our schoolings. Now, we are going to discuss how these electrodes are useful in medical applications. First, let us see the definition. Electrode is a device which converts the ionic potential into electronic potential. We know that our body is full of ionic potential. So we are having lots of ions in our body. So due to the movement of ions, it will create some potential. So this ionic potential should be converted into electronic potential. With the help of electrode, we are measuring that. Okay, we are measuring that in the form of signal. So the signal may be ECG signal. ECG means electrocardiography, which belongs to measurement of heart signal. Okay, next EEG signal, electroencephalography. So EEG signal is used to measure the potential from the brain. EMG signal, which is electromyography, to understand the muscle activity. Okay. Now, the potential we are measuring across the electrode and electrolyte interface. So, we should know what is interface. We know that what is electrode, but we have to know how this electrode and electrolytic interface can produce potential. Now, see this diagram. Here we are fixing two electrodes on the chest of the patient, isn't it? Now, we have to measure the potential across this. Now, the body is fully filled with fluid. That fluid is called as electrolytic solution. Am I right? So, across this solution and electrode, the potential is generated. So, we are measuring this potential using these two electrodes and we are displaying in the display unit. Now, let us discuss about different types of electrodes. There are different types of electrodes. First one is body surface electrode. Second one is needle electrode. Third one is micro electrode. So, let us discuss all the topics one by one. So, first topic is body surface electrodes. See, these are the different types of body surface electrodes. So, this electrode is used to sense the potential from heart, brain and nerves. See, the first type of electrode is immersion electrodes. Second is plate electrodes or metal plate electrodes. Third one is metal disc electrode. Fourth one is disposable electrodes. Fifth one is suction cup electrodes. Sixth one is floating electrodes. Seventh is flexible electrodes. The last type is special electrodes. So let us discuss all the topics one by one. These are the very easiest topics. You can understand the concept very easily. See the first topic, immersion electrode. See the title, here we are having the word immersion. So the electrode, which is the oldest type of electrode. This is the first type of electrode. See here we are having two buckets. See, these two buckets are filled with some saline solution. So, what is saline solution? So, the water which is mixed with some sodium chloride. So, that is called a saline solution. So, we are keeping hand and leg into the saline solution. So, the main drawback is oftenly we have to clean this saline solution. We have to change the saline solution and we have to clean the bucket. So, that is the very difficult process. So this type of electrode is not a comfortable method. So we have to go to some other electrode. Okay, already we have discussed this is the first type of electrode, and here we are using saline solution. After that, it is not a comfortable type of electrode. So it is replaced with metal plate electrodes. Okay, now we are going to metal plate electrodes. See here, this electrode is in the form of metal plate. So this is the metal plate electrode. This is metal plate. Here we are having one conductor. Also we are having one lead wire. So lead wire terminal, it is acting as a connector. So this is the most useful electrode. It is having very smallest contact surface area, and here we are applying gel before fixing the electrode on the patient. The main problem in this electrode is electrode slippage. So if you are fixing the electrode properly, we can measure the accurate signal. So if the electrode is slipped, definitely we can't measure the signal properly, isn't it? So there is a displacement of electrode because it's having a tendency to lose the adhesive ability. So this is the main drawback of this electrode. So it may lead to some measurement errors. So due to the slippage of electrode, the measurement error may occur. Okay, so that we are moving to metal disc electrode. So this electrode will be in the form of disc shape. See this figure? So this is the metal disc electrode. Here the lead wire is connected. The insulating material used here is epoxy material. Okay. Now, let us move to the fourth type of electrode, that is disposable electrode. Here we are having the word disposable. So, this is the only one-time usage of electrode. So, we can't use the same electrode for multiple purpose. So, many times we can't use that. So, only one time we have to use this. This is the disposable foam pad electrode. So, when comparing all the types of electrode, this is the electrode which can be used only one time. See, all the previous electrode we can use more than one time, isn't it? So this electrode can be used only one time and it should be disposed after the use of it. So this is silver plated disc, and here we are applying some gel before placing on the patient of the body, and it need proper cleaning. Before fixing the electrode, we have to clean the patient's skin. Okay. So these types of electrodes are mostly used because this is very cheapest electrode. So we can use this oftenly. Now let us move to the next electrode, that is suction electrode. Suction electrode is also called as Welsh cup electrode because the shape of the electrode is in cup shape, right? So this suction electrode is also called as Welsh cup electrode. See these figures. So this is the real-time electrode. This is also the real-time electrode. So this is the pictorial representation. For easy understanding, I'm showing this. See, this is lead wire. This is contact surface area. This is rubber bulb. So this is very smaller surface area, and here we are using one rubber bulb. What is the use of the bulb? Can you guess? Can you guess? When we press the bulb, automatically we can fix the electrode on the surface of the patient. So we have to squeeze the bulb. Squeeze means we have to give some press on this bulb. Okay. So here no need to use any adhesives. It is suited to fix on the flat surface of the body. It's a smaller surface area. It is having very good contact surface because we are fixing on the flat surface of the body. So it's having very good contact surface. It's mainly used in ECG measurement. We know that ECG means electrocardiography. So it belongs to heart. Am I right? So to measure the condition of the patient's heart, we have to take ECG measurement. So the bulb should be squeezed. That means we have to give some press to the bulb so that we can fix the electrode on the surface of the body. The main drawback is if you are fixing on the surface of the patient, it may give some irritation to the patient. That's the main drawback. So it needs more cleaning procedure. So that we are moving to floating electrode. See the title? It's a floating electrode. The electrode which is floated on the surface of the body. There is no direct contact between the surface and the electrode. Can you see this figure? Understand? So it avoids artifacts. What is the meaning for artifacts? Artifacts means disturbance or error. So if we are fixing the electrode properly on the body surface, we can get accurate signal. If there is any displacement, there may be a possibility of error. So if you are using this floating electrode, there won't be any error in the measured signal. There is no need to make direct contact. Already told this point. And the conductive part between the metal and the skin is the electrolyte paste or gel. Okay. So the contact surface which is coated with some gel. Okay. So this between this skin surface and the electrode we are having gel. So this is the pictorial representation for understanding purpose. See this line. This is skin surface of the patient. Here we are fixing the electrode. This electrode is made by silver chloride. Here we are having some space. This space is for filling electrolytic gel or paste we can say. Here we are connecting the lead wire to make connection with the display unit. The main advantage of this method of this electrode is it can give more stability. Already I told that. What is stability? See, it can provide accurate result. The electrode is in floating stage even though it can give exact result. Okay. So this type of electrode can give good stability. That is the main advantage. So that I have shown the example for remembering this word stability. I have shown this figure. Now we are moving to the next type, that is flexible electrode. So this electrode is more flexible type. See this? This is flexible type electrode. Here if you use this electrode, it will avoid most artifacts. It will avoid errors and it is mostly suitable for babies. And here also we are using some gel. So for monitoring premature infants, we can use this flexible electrode. So this flexible electrodes are having very good advantage. It won't give any irritation. So that only we are using this for premature infants. Now the last type of body surface electrode is special electrodes. See this? This is one of the special electrode called as ear clip electrode. Also another special type electrode is scalp surface electrode. See, we are having the word scalp. So this electrode we have to fix on the scalp of the patient. So this scalp electrode can be used to measure the EEG signal. EEG means electroencephalography, to understand the condition of brain. Okay. So the best method to measure EEG signal is 10 to 20 electrode placement system. Okay. In the next session, we will discuss about this concept 10 to 20 electrode placement. So this electrodes can avoid measurement errors or movement errors. So it is also useful to measure the heart condition of babies. So when the baby is in mom's uterus, the heart condition can be identified by using the scalp electrode. See this? This is the example diagram for ear clip electrode. This is EEG scalp surface electrode. Okay. So for better understanding, you can refer the previous diagram, ear clip electrode. So it will be easy for understanding. So up to that, we have discussed different types of body surface electrodes. I hope that you have understand the concepts. So now totally we have discussed 8 topics under this body surface electrodes, isn't it? Now let us move to the second important type, needle or internal electrodes. Needle electrode. So needle, N for nerve. So this electrode is used to record the nerve action potential. So this electrode is used to measure EEG signal and EMG signal. Already told that EEG means electroencephalography, EMG means electromyography. Okay. So this needle electrodes we are not directly inserting into the brain. It will just penetrate the skin. See, this is the figure of needle electrode. Here we are analyzing the muscle activity of the patient. There are different types. First one is insulated needle electrode. So this is the figure of insulated needle electrode. See this? Here the needle electrode is very sharp and this is coated with some insulating material. Again it is protected by some plastic hub. Again it is ended with lead wire. So this lead wire is acting as a connector. The solid needle, this needle which is made up of stainless steel. That is an important point in this topic. Okay, already told this. Plastic hub we are using for giving protection. The second type of electrode is coaxial needle electrode. Here we are having the word coaxial. So definitely we are using the wire coaxial cable. See this, both the diagrams are almost same. The difference is here the point is very sharp. See this, here we are having additional wire, right? That is the difference. Okay, so here we are having the wire. It is also called as the central electrode. It is coated with insulating material. Again, it is protected with plastic hub and ended by lead wire. The insulating material we are using mostly is epoxy resin. Next type of electrode is bipolar coaxial electrode. See the word bipolar. So here we are having two wires. See the previous figure. Here we are using only one wire. Here we are having two wires. So more than one wire we have to use, right? So again the same concept. It is coated with some insulating material and here we are using one protecting hub and it is ended by lead wire. The fourth type of needle electrode is fine wire electrode. Here we are having the word fine wire. So in this electrode we are using the minute wire or fine wire. See this? This is the fine wire which is in J-shaped structure. Right? J-shaped structure. Again insulating material is there. It is coated with some insulating material like epoxy resin. Again it is the protection hub. Plastic hub we are using and this lead wire is used as the connector. The fine wire diameter is 25 to 125 micrometer. Already I told that this is the very fine wire. So the diameter is micrometer range. Okay, 25 to 125 micrometer. Now, needle electrode which is used to measure the EEG signal, I already told that. See, this is the needle electrode. See, this is the connector. Now, we are fixing cap on the scalp of the patient and we are keeping this needle electrode to measure the potential from the brain. So, this signal will be measured in the display unit. The signal is called as what? EEG signal, electroencephalography, to understand the condition of brain. Okay. Now, this is the needle electrode which is used to measure the EMG signal. M for myo or muscle. See, the muscle activity can be measured by using this EMG needle electrode. Right. The main advantage of this electrode is it is less susceptible to movement errors. So, the errors will be very less. Okay. So, there won't be error in this needle electrode. So, up to that we have discussed the types of needle electrodes. We have discussed 4 types of needle electrodes and how we are measuring the potential from the brain and muscle we have discussed. I hope that you have understood up to this. Now, let us move to the third type of electrode, microelectrodes. Okay. So, this is the last type of electrode, microelectrodes. See this figure, this is the microelectrode. It is a very small size electrode. It is used to measure the potential within the cell. See, the important point, it can be used to measure the potential within a cell. So, the electrode is called as a microelectrode. So, the diameter will be in micron range. See, 0.05 micrometer to 10 micrometer. So, this is the diameter of this electrode. So, if we are fixing the electrode on the cell, definitely it won't damage the cell. Because we have to insert the electrode on the cell, isn't it? So, by the structure of the cell won't change. It won't damage the human cell. There are 2 types. First one is metal microelectrode. Second one is micropipette electrode. First, let us discuss what is metal microelectrode. See, metal microelectrode. So, this is the sample diagram. See this. This microelectrode is very sharp. See the length of this needle is 5 millimeter, and the length of the insulating rod is varying with different sizes. It may be 2 inches or 3 inches or 5 inches. Okay. Now here we are having shaft. Shaft is acting as the connector or medium. So it is connecting this rod and the connector. Okay. Already we have discussed lead wire, that is acting as a connector. Understand? See, this metals used for manufacturing this electrodes are stainless steel, platinum iridium alloy and tungsten. See, this is the pictorial representation for understanding purpose. The same diagram. See this. This is the needle. Here it is coated with some insulating material, and here we are having shaft. It's acting as a connector or it's a medium, and it's ended by lead wire. So lead wire is acting as a connector. Next type is supported metal microelectrode. There are two types of supported metal microelectrode. First one is metal inside glass. Second one is glass inside metal. So metal inside glass means, see here, it is a glass tube, okay, which is filled with metal. Here the tip, this is used for measuring the potential. We are not using any coating at the end of the tip. Can you see this? Now see the second type, glass inside metal. So here it is filled with glass. Again it is coated with some metal film. Again it is insulated with insulating material. But we are not coating the tip with insulating material. Except this tip we have to coat the remaining places. Right? So this is called as supported metal microelectrodes. Now the second type of microelectrode is micropipette electrode. So this micropipette electrode, which is made by glass, also it is filled with some electrolytic solution. See this? So this is the glass tube. First we are going to heat this glass tube till it reaches some constriction. We have to heat. After that we have to pull this. So it will go to break at this place, isn't it? Now after breakage we will get two pieces. Am I right? So now let us take only one type of micropipette electrode. Here we are ending this electrode by some cap. This lead wire is used to connect with the display. Am I right? This tip we have to fix on the cell. It will measure the potential on the cell without giving damage. Already we had discussed. This is micropipette electrode. This electrode we are fixing on the cell. You know the structure of cell. This is cell. The outer layer is called a cell membrane. Also we are having nucleus, cytoplasm, everything you know that. Now we are fixing this micropipette electrode on the cell. So this micropipette electrode is made by glass and it is having stem. Okay. So this micropipette which is filled with some electrolytic solution. Already told that it is a glass micropipette. The diameter of this electrode is 1 micrometer. See here I told that here we are having stem. The stem is made with different materials, chloride silver, stainless steel or tungsten. So these are the different materials used to make this stem. So now we can measure different types of potentials from different parts of the body. While we are choosing the electrode, we have to see some parameters or properties. We have to understand first. The first property is the electrode should be a good conductor. So if it is a good conductor, then only it can measure the potential accurately. It should conduct current. Okay. Second point, it should establish good contact with the body surface. Without slipping, it has to make a proper contact on the body surface. Third point, it shouldn't create any irritation to the patient. It create any swelling. Am I right? So which type of electrode will create some irritation to the patient? Can you remember? Of course, it's a suction electrode. Suction electrode is the best electrode, but it will create some irritation to the patient. So we have to see this property also. If you are choosing electrode, it shouldn't create any irritation. Next point, while we are fixing the electrode on the patient, it shouldn't chemical react. So it should not be toxic. That's an important property. Next property, mechanically right. What will you say? What is the meaning for this? The electrode may be uneven even though it should give exact measurement. So last point, if you are choosing the electrode, it should be very easy to clean. So the electrode, before we have to fix the electrode, what we will do? We have to clean the surface of the body, and some type of electrode always we have to clean that. If it is a disposable electrode, we don't want to clean that. Immediately we can dispose that. But if you are reusing the electrode, we have to clean the electrode oftenly. Okay. So these are the important properties of electrodes. Now we have discussed. What are the topics we have discussed? Three topics we have discussed. First one is body surface electrode. Second one is needle electrodes. Third type is microelectrodes. See, these are the important types of electrodes which are used for different measurements of potentials. So now let us discuss what are the applications of electrodes. Already we know that it is used to measure ECG signal. ECG means, do you remember? Electrocardiography. It belongs to heart. See this figure? Here we are fixing the electrodes on the chest of the patient, and these electrodes are connected with ECG machine. So this machine will display the ECG signal, and we are taking, it is connected with the printer, and we are recording the signal. Okay. Second application is, it is used to measure the EEG signal. We know that EEG means electroencephalography. It is used to identify the condition of brain. See this figure? Here we are fixing the electrode on the brain, and we are getting different kinds of waveforms. So these are the different characteristics of EEG signal. So later we will discuss this topic. Okay, this is one of the very important topic, ECG, EEG. So everything we will discuss in the next session. So how to measure the EEG signal, how we can analyze different types of signals, everything we will discuss in the next session. Now the third application is used to measure the EMG signal. M means myo or muscles. So EMG signal means, since electromyography, it is used to identify the condition of muscles. See this figure? Here we are fixing some electrode to identify the activity of muscles. So these are the main three applications of electrodes. So you have to remember ECG, EEG and EMG. Okay. I hope that you have understood the session. Now let us conclude this session with a positive quote. The key to success is to focus on goals, not on obstacles. So keep learning more. Keep on trying to achieve a success.